How are you?
Yeah, I'm good.
Good evening, Himanshu.
Good evening.
Yeah. So after a long time, you are coming back, no?
Yes, it has been a very long time. Yes. In fact, actually, there was one thing that I wanted to particularly ask. I think most of you must have faced this sometime, but I don't think the discussion was carried out on this. I wanted to ask about the placement of three saddles.
Mm-hmm.
Because in two saddles it is very generic. All of us are doing whenever a horizontal equipment is mounted on two saddles. But how to take care of three saddles?
So your query is where the placement of this third saddle and how it to be located, right?
Yes.
Okay. Okay, Ramakrishna or Mali, you want to answer?
I think PVElite we can add multiple saddles.
Yes. In PVElite it can be added, but the thing is that in many reference books I have seen that the placement of the third saddle becomes a big problem because it may happen that the load is not equally distributed.
Yeah, correct. It should be you try to put it as near to CZ as possible.
Yes, and in fact, in the PVElite, when I added the third saddle and I had the file run, then the computation of the results was also not the way it should have been. Because the PVElite is not accurately taking care of the third saddle.
Yeah, correct. Yeah.
Normally, what we'll do, this two saddle, no, it's point to from the end where we normally use to place, and whatever the remaining distance between these two saddles, no. So in between that we used to keep this third one.
Yes. Same method I also used to follow, the 10 line to 10 line distance divided by the number of saddles.
Yeah. So we used to do like that only. Then it will be, we consider that this all the loads will be distributed in equally on all three like that. So, but in PVElite, this third saddle is a new, means recent. It's not as you said. It's not take care of that one. It's only maximum. It takes of two saddles is analysis of that one. Third one just as a temporary they will consider and they will take as just as a additional things in that one.
Yeah.
So, but two saddle and this third saddle, because this PVElite report and that one, what your it gives, so maybe it will be. We hope that it will be correct. And other books also is not given that much. Dennis Moss there given something in that one, but not that extent.
Himanshu, I suggest you maybe your structural guys can help in that case.
Yes, maybe, or maybe FEA will.
Yeah, FEA is fantastic. I mean, you need not ask anybody.
Yes.
Yeah, better.
Because,
FEA again, it is a complete. Again, they have to model the complete vessel. Then they have to add the saddles in that one, and which portion particularly it's failing. That portion they need to verify, and then they have to analyze for FEA for that one. So again, they have to all three saddles they need to analyze, and then they have to verify where actually failing in that one.
One FEA person.
I mean, actually, how big the vessel is, Himanshu?
Actually, it is a thin-walled vessel, quite a long, a column you can say, not a vessel, a column.
Horizontal column, you can. Yeah.
Yes, vertical column actually placed in horizontally during the transportation.
Oh, so
okay.
So you want to analyze only for transportation? Okay.
See, for transportation, we assume that it won't be a much governing factor because after that the vessel is going to be placed vertically. That is fine. But I have seen cases wherein the horizontal vessel itself is having a 10 to 10 length of about more than 30 meters.
Yeah.
And
but what is the weight? I mean, how can you specify the dimension just to have an idea?
The vessel that I had seen, it was the diameter, you can say it was of medium size, around 2.5 something, and the pressure was less. Pressure was around 3 kg. So the thickness calculated was also not that much. But the thing is that it was.
But you are saying the height is more. How
Yeah, the 10 to 10 length was more.
How much? How much?
Around 30 meters it was.
So it was okay. What is the thickness used? Whether it is okay for the deflection? That's why I'm asking. Whether you checked for the deflection?
Yes, actually the problem that we were facing is that there was a sagging at around the center of the equipment.
Okay.
Because there is a limitation to where the saddle can be placed. In Denismos, if you see,
No. I'm not asking about the transportation. I'm asking in the vertical condition. If you are using such a low thickness, whether it was okay for.
No. This vessel is different. What I am talking about. The vertical one was different. That is particularly for transportation case.
Okay.
And this horizontal vessel that I am talking about, this is different. This is where the saddle will be welded to the shell.
Okay.
There are two different cases. One is only for transportation, and one is a horizontal vessel wherein the saddles are permanently attached to the shell.
Yeah. I can suggest you one solution with maybe 2 saddles. What you can do, out of this 30-meter stretch, maybe where your saddle is welded, locally you can increase the thickness and you can do it. That is one way of doing it.
And one more is that, as you said, number of saddle you can increase. You can increase by looking where it's sagging. On that place you can add some more.
Yes, that is what we did. We divided the 10 to 10 length with the number of saddles that we were using. 3 saddles in our case.
Okay.
So we placed the third saddle at the distance of 1/3 from the other two.
Okay.
But the thing is that there was no proper way to verify that the third saddle was taking the effect that it should take.
Okay.
That is the problem.
Okay, Abhishek or Anshu, you want to add something in this one? Because he want to know the third saddle adding in the horizontal vessel.
What?
Actually, he is a long vessel is there, and he is adding more than 2 saddles in that vessel. So third saddle in PVElite does not give the correct answer or correct results on that one. For that one, he wants some authentic any solution if we have.
How long exactly?
Around 30 meter, 10 to 10 length.
30 meter, no? Then 2 should be sufficient. What is the weight actually?
The weight exactly I don't remember, but it was around. It was, I think, more than 50 tons. It was, as far as I can remember.
The thing with 3 saddle is there is a criteria for saddle sinking. Just how do I say it? Assume one of the side of a saddle might sink even if it goes 2 mm down. Na? The weight distribution would become uneven and the saddle would be failing. That's why we had a similar case of a 40 to 50 meter vessel, but considering the saddle would result in a much more complex problem and equations, solving them the way 2 saddle are designed would not be a correct method.
So you are suggesting go for 2 saddles only, right?
Yeah, 2 saddle or FEA.
Yes, correct.
Okay. For FE also to model that one, we need to inform them whether we need to go for 2 saddles or 3 saddles. Then they model that one and they'll analyze accordingly.
To verify.
Yeah. So as per your suggestion, you want to we need to go for 2 saddles only. But normally when longer vessels are there, on that time we used to go for 3 saddles, and we divide the total length in from 0.2 to means whatever the available the distance between them, and accordingly we will make that equally placed that saddles.
Yeah, I think you better to do FE. I think.
Has anyone used compress?
I have little bit.
Okay, so has anyone tried this in compress? Because maybe.
No.
Okay.
Okay, Himanshu, you got whether you have to try with FEA or okay, Abhishek, you want to add something?
Abhishek has some query actually.
Yeah.
Yeah, Abhishek.
Hello?
Yeah, Abhishek. You can.
Yeah, good evening everyone.
Yeah, good evening.
As we all are discussing about saddle support,
Yeah.
recently I came across one problem with the design calculation of saddle support. There was a warning error in the PVElite which was failing at the horn of the saddle.
Yeah. You want to add with his issues, or yours is new one?
No, actually, I'm just adding my issue.
Okay.
Because since we are discussing about saddle support. So
Yeah. Can we finish his? I think Himanshu, yours.
Okay.
It's clear now, or you have any doubts in that one?
Yes, it is clear. And what Abhishek Nag is asking, that is also a very common issue.
Okay, Abhishek, you can continue.
So it was failing in at the horn of the saddle. So our consultant, they suggested to increase the wear pad length, okay, and then you will resolve the issue. Understand, with that we were able to resolve the issue.
Actually, it is not wear plate. It is actually saddle angle unit increase. That is one option.
Okay.
Your saddle included angle, no? So that has to be increased.
Generally, we take 120 degrees, right?
120 degree. Instead of that, you can go as high as I think 160. Also, you can go.
Means it's covering more area of your vessel.
Yes.
The thickness, when you cover more area, the thickness, that part thickness will be increases.
Yeah.
So it will take care of that horn, whatever the stresses and
So actually, your loads are distributed equally. So that is one option. And the second option is you can add saddle rings.
Yes.
Actually, what Mr. Abhishek suggested, the person whom has suggested Mr. Abhishek is also right, because what happens is that when usually we take the wear plate width less than the calculated value, so PVElite completely ignores that width. So whenever we are taking the width more than the calculated value, it is taking the full effect of the width. So the entire stresses, it is considering that it is distributed along the width of the wear plate. So that is also one method, because I have personally tried that.
Yeah, but PVElite do not consider any effect because of that. No?
Yeah, it does consider, because if you increase the wear plate width by a value more than the minimum calculated value of the wear plate, then it takes the entire effect of the wear plate, and the circumferential stresses at the horn of the saddle, it considerably decreases, and at times it goes below the allowable value as well.
Okay.
Because there was a case wherein I was designing a heat exchanger, and the same problem I was facing, and we did not wanted to opt for the stiffening ring, because that stiffening ring has a separate set of stresses of itself.
Correct.
So I tried multiple permutation combination, and then I found out that if we increase the wear plate width to a value more than the minimum calculated value, that is V plus 1.56 root of RT. If we take a value higher than that, then it takes the full effect of the wear plate.
Correct.
And then it distributes the stresses along the entire width, and then the value of the stresses generated considerably decreases.
Okay.
For example, if you have suppose the maximum allowable stress that the wear plate can take is suppose 120 Newton per mm square, and suppose the minimum calculated value of wear plate is 348. So when you take the wear plate width less than 348, suppose 345, then it completely ignores the width, and when you take 350, then it takes the entire effect of the width, and then the stress generated considerably goes down. For example, those stresses that were going suppose 138 Newton per mm square will now be reduced to around 60 Newton per mm square.
Okay.
But normally when why we take the less than that one? Normally whatever the minimum required, we normally take above that one. No, will not go below that one.
No, we take below that, because if you see in many client specifications, even the reputed specifications like EIL, the minimum width of the wear plate is much lesser than the calculated width.
Correct.
the width that they have specified.
Yeah,
Right.
lesser than there in standards they shown that one, but when calculation shows that we require suppose we require 100 and their standard saying 80 mm, so we don't go for the 80, no. At calculation shows that 100, so we need to go minimum as 100 because calculation giving us minimum.
No. Actually, Ravi, that is not mandatory actually.
Correct.
So, yeah. So that's why we generally stick to standard, even if there comes a warning. Your width of the RF pad is less than the recommended, so I am ignoring it like that.
The effect of the wear plate is ignored in the calculation.
So mostly I'm not deviating from the standard, so I'll keep it. But if it is
So,
but we
are
can
ignoring the
new
error.
options.
So if
Yeah,
we are
I'm-
ignoring the error, will it not have any adverse effect on the saddle?
Sorry, can you repeat? Sure.
I'm asking that if we are ignoring that error,
Yeah.
okay, then will it not have any adverse effect on the?
No, it doesn't have any adverse effect unless, see, what happens is that whenever we weld the saddle at the shell junction, the stresses are induced in the shell, and the wear plate is provided as a local reinforcement. So what happens is that when the wear plate effect is ignored, the PVElite is assuming that the saddle is directly welded to the shell, and the stress distribution, the entire stress distribution is on the shell. But when we take the width of the wear plate more than the minimum calculated width, it takes into effect that effect of reinforcement. So the stresses in the shell are considerably reduced.
Okay.
In your case, wherein the circumferential stress at the horn of the saddle were the reason of failure, this method of increasing the width of the wear plate is a very safe and very good method, in fact.
Okay.
Because in many good engineering practices, if you see, they say that stiffening ring should be avoided. In fact, Dennis Moss itself says that stiffening ring should be avoided as far as possible.
Yes.
okay, as Himanshu told that, so wear plate we need to consider more than that what given in PVElite and that one.
Yes.
So even the standard says that less, so we have to go with higher whatever the comes in the calculation, and we have to show to the client if we get the value higher than that what in the standard shows to the client.
Yes. Correct.
And as Abhishek, your problem, as Himanshu told that if you increase the length, means what is the width of that one, so your problem gets solved with that one.
Yeah, it is resolved like that.
So Ravi, we can conclude like this. Then, if we face such a situation, then there should be three options. First option is increase your wear plate width to the minimum recommended. So if that solves, that is okay. The second option is, next step is increase the saddle angle.
Yes.
And even if that is also not passing, then the last option, which is not recommended, to add the stiffness.
Saddle ring, correct.
Yeah.
But whenever you are using the first and second option,
Yeah.
there are 99.9% chances that your saddle will pass.
Yeah. So that, yeah, we have to conclude.
Okay, Abhishek, you got your answer.
Yeah. The second question regarding the saddle support is that I just want to understand how do we fix the position of the saddle support? Like we have a 20 meter of horizontal, it's a horizontal vessel, 20 meter of length. So generally we take from the tan line, right?
Yeah, correct.
So how do you decide that I have to place, suppose 500 mm or 600 mm from tan line?
Yeah.
How do we decide?
Yeah, I'll tell you that. There is a direct criteria given for that in the Dennis Moss book itself. The saddle should be placed from the tan line at a distance of 0.2 or 0.5 times the radius. Half of the radius or 0.2 TL to TL, lesser of the two. Because your dimension A, that is the distance from tan line to the saddle, should be as less as possible.
So minimum 0.2 you have to take that the length, tan to tan length is there, no? That length you multiply with 0.2, and whatever value you get, you have to place your center line of your saddle to be placed.
0.5 or or point to TL lesser of the two.
Yeah.
And it may not always happen that your saddle is placed from tan line. It may happen that the distance of saddle is taken from the tube sheet. So basically that is distance of saddle from a line of support.
Okay, Abhishek, you got or still?
Yeah, I got, yeah, very much.
Yeah,
I got the
Anshul, you want to
clarity.
add something?
Point to 20% of the length or 50% of the radius.
Yes, lesser of the two.
Lesser of the two. Right.
Yes.
Yeah, very much. Thanks.
Yeah, Anshul, you want to add something?
Yes. Yes. Abhishek, you can just refer the chapter 4.10 of Dennis Moss. There is also a trial and error method of how to design a saddle completely given there.
Sure.
Got your answer?
Yeah, I got that.
Okay. Any more you have?
Okay, there is one thing that I wanted to ask. Again, that is a very common issue that I think most of us must have faced. We all are aware that the nozzle flanges, when derated as per UG44B equation, has few criteria that has to be satisfied.
Okay.
Whenever we are using that equation given in UG44B4. So my question is that those flanges, as far as I have checked, they are not passing in the PCC1 appendix O.
Okay.
There is a criteria in UG44B3 that the flanges should have the assembly bolt load as per PCC1 non-mandatory appendix O. But the standard flanges of B16.5 do not satisfy that criteria. They are failing in that criteria. So how others are mitigating that issue?
Would you want to answer this? Yeah, Ramakrishna, you want to answer something?
No, actually, I didn't come across this issue.
Do you have this one? What Himanshu actually this 44B that you want to?
PCC1.
Hello?
Yeah, Anshu.
Yeah.
Your flange is filling in PCC. Hello?
Hello. Yes, Anshul.
Yes. So your flange is filling in PCC calculation.
Yeah, it is filling in PCC1 appendix O. The standard flange.
I don't think it should because I have provided like 60 to 70 flange recently and all of them were calculated using PCC also and none of them had any problem.
This flanges as per B16.5 you are talking about?
Yes. What I'll do, I'll share you a calculation tomorrow or day after tomorrow.
Okay, great.
Yeah.
Himanshu, if you have yours error or whatever you face the problem, that if you have, you can share. So we will look in that one because normally we didn't face this issue with our calculation.
See, what I have seen, what people are doing is that they are using the equation of UG44B4, but they are not complying with the other requirements. Most of them are not checking the flange itself for PCC1 appendix O.
No, if you have any that error or something with you now, if you can show us, so we will just look in that one.
Yeah, I'll just I'll just try that out in an Excel sheet using the dimensions of this B16.5 and the failure one I'll share.
Okay.
Meanwhile, Anshul, it would be great if you could share the one that you say it is passing.
I have one issue.
Yeah, Anshul, normally Anshul he will share, he is told that he will share. Okay, Ramakrishna, you can proceed.
Yeah. I'm designing a Division 2 vessel. So, in that there is a 2-inch flange, 2-inch nozzle, which is and it is SR5 per WNRF type nozzle. So it is from the decision joint, no? That from the discontinuity, I have a lot of distance. It is not. It is very far from it. Approximately around, I should say, minimum I have a distance of maybe 300 mm gap or something. So, and I have limited the reinforcement also area. That I will limited the diameter also. Still, PVElite shows that there is a overlap of your discontinuity and the PVElite error, or how anybody can.
your issue is that the distance between the pads and weld, it's
Yeah, actually, as per division 2, so that discontinuity, what is talking about is to that it is spherical to the our shell. We will provide a 1:3 taper, no? So there it is a structural discontinuity. Means their shape is changing. So that to that point and your limit of reinforcement both should not. Affect. So there should be a gap. So but there is a clear gap. Anybody face this issue?
So you are getting a warning of gross structural discontinuity, is it?
Correct. Yeah, he's saying it's a overlap, but there is enough distance is there, but still.
From the limit of reinforcement, that means from the edge of the pad. No, there is no pad. Sorry, yours
No
is
pad.
reinforcement.
Yeah. So what I have done, I limited the diameter to 75 mm only.
Okay.
So even then it is passing. It is a 2-inch nozzle. So it is passing, and from the edge of this nozzle to the where the bevel start, I have at least 300 mm. So, but still, PVElite says that it's a overlap. This I didn't understand.
300 is quite a considerable distance.
Yeah.
300 is not a very small distance.
Yeah. But I just checked when I make it, it is a 2-meter shell. So I made it maybe the 3 meter, 4 meter, then it is passing. I don't know.
No, then there is a 4 meter. You are saying that from the location of discontinuity.
So what I have done is, okay, let me increase the shell length so that where it will pass. So,
Okay.
yeah.
No, that should not happen actually, because 300 mm itself is not a very small gap from the discontinuity location.
I don't know why. But anyway, I closed and I written a remark that this is enough gap. So they are ignoring like that, and I sent it. But anybody have this issue? Anybody faced?
One thing I wanted to ask is, along with the warning, is it giving any minimum distance that it
No, nothing.
Just the warning of gross structural discontinuity.
Yeah, that's it. Yeah.
Because we had a case wherein this similar issue was there, wherein descent to shell joint it was, and it was a vertical equipment, and
Yeah, mine also vertical equipment. Yeah.
okay, and the nozzle was placed as close to weld line as possible. It was a process requirement. Instrument nozzle it was.
Oh, yeah.
So there also we were getting a warning of gross structural discontinuity. And in that method in Bednar, the distance from this discontinuity is also there in that equation. So that actual stresses can be calculated and then it can be compared with the allowable. Or else FEA can be done.
Yeah.
okay. FEA can be done. I think if it is a very nearer to that, or it's failing. But in his case, even more than 300 mm is gap is there. Still, it's showing some error. Means it's maybe some software or something. Maybe.
Yeah, it must be something with the software.
Yeah.
Because 300 mm is not a very small gap.
Yeah. That's everything. Okay. Anybody face this type of issue? Means even 300 gap is there in the weld to weld. Still, it's showing some errors or something. I think nobody. Okay, Ramakrishna, I think it's as software error maybe, or you can try if you get any.
I added a remark and send.
Yeah.
Let's see what clients say.
Okay, even if client written that okay, you have to remove the error, then you have to follow the Himanshu advice that refer some. Okay, any more?